Good morning, my YouTube viewers. Crystal here. What I wanted to do today is I wanted to talk to you about class imbalances. And what I've done is I've selected a competition question from Analytics Vidhya that I have used before. And but what I've done is I've cleaned it up a little bit, and I'm going to talk to you about it with the express intention of talking to you about it with the class imbalance. This is a really good example of a class imbalance, and that's why I'm using it. And I'm going to discuss with you 3 ways that you can correct for a class imbalance. With this particular question, it was an agricultural question from Analytics Vidhya. It's on my GitHub account, so you can see the name of my GitHub account if you want to look it up and follow along with me. So the first thing we're going to do is we're going to go over the problem statement. The problem statement is the toxic pesticides. Since though many of us don't appreciate much, but a farmer's job is a real test of endurance and determination. Once the seeds are sown, he works days and nights to make sure that he cultivates a good harvest at the end of season. A good harvest is ensured by several factors, such as availability of water, soil fertility, protecting crops from rodents, timely use of pesticides, and other useful chemicals in nature. While a lot of these factors are difficult to control for, the amount and frequency of pesticides is something the farmer can control. Pesticides are also special because while they protect the crop with the right dosage, but if you add more than required, they may spoil the entire harvest. A high level of pesticide can deem the crop dead, unsuitable for consumption, among many outcomes. This data is based on crops harvested by various farmers at the end of harvest season. To simplify the problem, you can assume that all other factors, like variations in farming techniques, have been controlled for. You need to determine the outcome of the harvest season, i.e., whether the crop will be healthy, alive, damaged by pesticides, or damaged by other reasons. So that's the problem statement for this question from Analytics Vidhya that we're going to talk about, and we're going to focus specifically on the fact that it has imbalanced data. So the first thing that we're going to do is we're going to import the libraries, and you can see the main libraries that we have imported. And then we're going to load the data sets. Now these data sets are on my GitHub account, so you are free to use them. I've loaded them up for the express purposes so I and other people as well as me can use them. So you're free to use the data sets on Analytics Vidhya on the GitHub account. They're also on the Analytics Vidhya website under it was under a hackathon, and it was an agriculture question. If you don't want to use mine, then you can go directly on the Analytics Vidhya site and use them. So we looked at the train file, and you can see the train file. One good thing about the train file is there were no objects. Everything was all numeric. So that was one good thing about the train file. Same thing with the test file. The test file is in the same format as the train file, except for the fact that it does not have a crop damage column. Your crop damage column is your dependent variable. It's your target variable, and the other columns are the independent variables. We've got our sample submission. That is the format that Analytics Vidhya wants to see when you submit your predictions. So we're checking out our train info for both train and test file, and you can see the ID number is an object and everything else is numeric. We've got a description of the train and test file. And then what we did was on our train and test file, we checked to see if there were any null values. And on the number of weeks used, we had null values that have to be corrected for. So what we've done is we have imputed the number of weeks on both the train and the test file, and we use the median value. The problem that you have whenever you have missing values, then what that does is that affects the outcome of the prediction, because you have to do something with the missing values. And since this is a competition, we can't just throw out the missing values. So we checked again to see if we had any null values after we imputed number of weeks used, and we don't have any more null values. So you can see the train and the test file. If we go over to number of weeks used, if you looked at that, you would see that all of the null values have been replaced with the median value. Now we have a graphical representation of the crop damage and how it relates to all of the different variables, and you can see that. Now what we're doing is we're pre-processing the data, and you can see that on the down here below, there's a graphical representation of that. So you've got a lot of 0, which means it's alive, and then you've got a few 1s, and then you've got just a tiny amount of 2s. So what we have to correct for is we have to correct for the 1s and the 2s, and the 2s specifically. And because there's hardly any 2s, it's highly likely that the model won't pick up the 2s unless something is done, unless some type of corrective action is done. Now you can see over here, when we did a group by of the group damage, you have 74,238 of number 0, 12,307 of number 1, and 2313 of number 2. And so if you add all that together, it is 88,858, which is the number of rows in the train file, because that's what we're going to be doing. We're going to be training, fitting, and testing on the train file, and then ultimately we're going to be testing on the test file. So what we're going to do, I'm going to tell you right now, we have 2,313 of value number 2. And what we are going to do is we're going to, when we use the train test split, we're going to split the training set up into 2 files. And what I have done is I have multiplied if you multiply 2313 by 0.1, then that's going to give you a 231. So that's basically how many of the outcomes are going to be of a number 2. That's how many they should be of a number 2 in the validation set. And we'll talk about that when we actually get to the train test split. But if you just keep that for future reference, that 10% of 2313 is 231. And that's how many number 2s we need to have. But unfortunately, I'm giving you this reading in the middle of the night, and my calculator is solar powered. So unfortunately, I can't get my calculator to work, unfortunately. But we'll try to see how we get on without a calculator. That just tells you how dependent. We have become on technology that, we need calculators and things like that to organize our daily lives. And so now we've got another visual representation of the crop damage, which I've previously showed you, and you can get another look at it, and you can see visually why the categories are imbalanced. And so I've given you lots of visual representations, which I did that in the beginning, but it's not really entirely necessary to do that. And basically what it does is it just shows you the frequency that these numbers are actually appearing in the column. So we've got the estimated insects count, and so most of them are under 1,000. We've got the crop type. You've got two types of crops, a 0 and a 1. We've got a soil type. We've got two types of soil, a 0 and a 1. We've got pesticide use category. We've got three types of pesticides, 1, 2, 3. You've got dosage frequency. You've got several dosages. And so that was put in a violin chart because there's so many dosages. It's going to be hard to put it all in a bar chart. And there's other types of charts you can use. I just used the most simple charts that I could think of, but there's lots of different charts that you could use to depict your data, such as box charts. We've got another violin chart on the usage frequency. So the most of the usage frequency is on a number 3. We've got another violin chart on the quit frequency. So most of the quits, that's the number of weeks that they haven't used pesticides, is 0. So that means they put a lot of pesticides on their crops, but they can't put too many pesticides, because if they put too many pesticides on their crops, then the crops are going to die from pesticide use. We've got seasons, so they've only included 3 seasons. I'm not sure exactly why that is. I don't know if it's because they don't do anything in the winter season, but they only have 3 seasons recorded. Now what we've done is we've done our feature selection, and feature selection is one way that you can allocate your which columns you're going to use. And we set up our train labels, and we've also, the train labels is the crop damage column, but it's been reshaped. And we've set up we've defined our X, Y, and X test values. So X is train features, Y is train labels, and X test is test features. Now what we've done is we've done a min-max scalar. So it's always a good idea to experiment with scalars. Now I personally have not had any luck with the standard scalar, but in this instance the min-max scalar did work. And then I set it up for a feature range of 0 to 2, because in the outcome of the crops it's going to be 0, 1, or 2. So we have smote, which in this program we used smote. I'm going to be doing a blog post where I'm going to be comparing smote to not smote. But in this program we actually used smote. That's a synthetic oversampling, and you do the synthetic oversampling to actually create more of level 2 outcomes. Here we had undersampling, which was called near miss, but we didn't use the undersampling, so you could either use smote or you could use near miss. Now, near miss is undersampling, where they just take a sample of the the highest outcomes in this instance, it would be 0, and they sample on that. But the problem that you have is if you oversample or undersample, then you can have a situation where you overfit or you underfit your training set. And if you overfit or underfit your training set, then that means when you go in to put the test set in the model, then it's not going to be very accurate. So that is one of the disadvantages of using SMOTE and near miss. And there are other tools that you can use to correct for imbalances, but I only decided to use SMOTE and near miss in this instance. Now what we've done is we have broken our training set into X train, X val, Y train, Y val, using train test split. Having a test size of 0.10. So that means if 2313 were number 2 in the training set, 10% of that is 231. So if the model was working at 100% accuracy, then we would have 231 number 2s in our confusion matrix, which we're going to be talking about that as well. You also need to set stratify up as yes, because that's going to indicate that the training set is imbalanced. And train test split will endeavor to balance the training set if you set stratify up to yes. Now we're going to use model selection, and I selected XGBoost in this instance. XGBoost is not part of the sklearn library, but you can use it with the sklearn library if you want to. Now, another thing that you can do is you can set up the hyperparameters, and the hyperparameters will help you with your category imbalance. And so, but what I have done is, because my computer is not very powerful, I'm going to need to get another one. And because it took me such a long time, I worked on this definitely Saturday and Sunday, and I was really exhausted. I had to reduce the parameters, but you need to have set your objective up as multi-softmax. The reason for that is because you have multiple numbers of categories. If it had been a binary, then it would be a binary logic. But because you have more than 2 categories, it has to be multi-softmax. I set the learning rate up to 0.01, in estimators 1,000, max depth is 20, and in boosting rounds is 1,000. But you have to understand, the more estimators you have and the more boosting rounds you have, the longer it's going to take for the model to work. And because my computer's not very powerful, and it took a really long processing time, and I was particularly exhausted, and so I reduced the parameters just to get this done, because I was really exhausted, because you have to spend a lot of time in front of the computer, waiting for it to process. So I reduced the parameters for that reason, but you can experiment and increase the parameters and see if you get anywhere. So when we use SMOTE and we tuned the parameters, we had a 97.60% accuracy. So what we did was we tested on the validation set, and when we tested on the validation set, we had an 89.05% accuracy. So one of the things that we had to do, because we're using XGB, is you can prepare the data to be used, because XGB is not part of the sklearn library, and because of that, some of the data is not compatible. So you can use something called dmatrix to prepare the data. So we prepared the data on xtrain, xval, and Y and X test. And so what we've done is we've set some more parameters. So we set max depth is 25, ETA is 0.3, silent is 1, objective has to be multi-soft max, and num class is 3 because there were 3 classes. So you'd have to set num class up for every class that you have. And num round we said 10. So the more, the higher the max depth is and the more the num rounds is, the longer the processing it's going to take. And so it was pretty exhausting for me to sit in front of the computer and wait for it to run through, and then it would error. It would go into error, and when it went into error, it meant that I had to restart it all over again. So now what we do is we set up our model for XGB train, and we calculate. And then what we do is we calculate on your D test, which is your X-val, really. And now what we've done is we've we've shown a data frame of the actual values in comparison to the predicted values for this XGBoost model that we have used, and you can see that the actual values in comparison to the prediction values is pretty accurate because it gave you an 89% accuracy. And now what we do is we check our scoring, because especially when you have an imbalance of data, you have to check your scoring to see, how you fared. And so our scoring, particularly our recall score, was 89.05%. And what we've done is we've created a confusion matrix. But since we use SMOTE, the confusion matrix gave you lots more samples, so we don't know. It had 67, 711, and 6937. If we hadn't used SMOTE and we hadn't tuned our parameters over here in this column here, the far right column would have been 0, because when I first started working with tuning the parameters and SMOTE, that's what I had was 0. And so what you need to do is you need to look at the confusion matrix whenever you are dealing with an imbalanced class, to make sure that the model is picking up these imbalances. Got another confusion matrix that was just done and a little bit classier way, but this confusion matrix here is just as good, although it doesn't have the labels and things. So we check our accuracy statistics, and again, you can see your precision, recall, and your F1 score, and again, our accuracy is 89%. So what we've done is we've created a file called dump_raw.txt. I've never used that file, but I haven't really been doing data science that long to actually use that file, but we created that file that you can use it if you want to. So now what we've done is we've created preds, and that's what we're doing. We're testing on the we're testing on the val. We're testing on D test, which was the X val, I believe. Yeah. And again, this gives you, when we test on the D test, that's the same as the X val. We have an accuracy of 87.93%. We save it into a pickle file. I've never used a pickle file, but a pickle file enables you to reuse the model if you want to reuse the model, but I've never done that. Then we check our feature importance, so you can see how important the features are. So now what we're doing is we're actually testing on the X test, which has now been called DX test. So we don't know what the accuracy is going to be, but when I put it on the Analytics VidHaya website, it was at 83%, but it just seemed to stay at 83% no matter what I did. It was stuck at 83%. But the highest percentage was, I think, 96%. So with this particular accuracy grading score that they used, you wanted to have the score as high as possible. So 83% was pretty high, but it just seemed to me that no matter what I did, it was stuck at 83%. And I'm not sure exactly why that is. And then so the final preds became preds. And then we created a data frame. And here's the data frame that we created, and that is what we submitted to Analytics VidHaya to get our ultimate score. So I just wanted to show this computer program to you. I think I made a video on it before, but I cleaned the video up, I tidied it up, and I labeled it, and I made sure that I put the libraries that I use in the actual section of the program that I was working on, because I've been tidying up all the programs that I used for the benefit of the viewers, and also because I started making blog posts as a little side hustle, but it's not a very big side hustle, but it's still a side hustle. And in order to do the blog post, I have to put the actual library I'm using actually in there with the code, so people will know what they need to do. So that concludes it for this presentation on the Analytics VidHaya Agricultural Hackathon question, with a special emphasis on data imbalances. I hope that this presentation has been beneficial to you. If you like my presentation, please like, subscribe, and share. If you like the work I do and you want to leave a donation, I've got my email address to my PayPal account down below. I don't have enough subscribers, so I'm not able to monetize my videos, and the only way I can make money on my videos is to actually ask for donations. So thank you so much for watching my video, and I look forward to making the next one for you.